Let's start with the foundation of every computer, the motherboard. Picture this as the central nervous system of your machine. It's essentially a sophisticated circuit board that serves as the meeting point for every single component in your computer. Through its intricate network of pathways and connections, it orchestrates the flow of electrical signals and data between all parts, ensuring they communicate seamlessly. While it might be the backbone holding everything together, surprisingly, it's often one of the more affordable components you'll purchase. Think of it as the stage where all the performers come together to create magic. Now let's talk about what many consider the true powerhouse, the CPU, or Central Processing Unit. This incredibly small chip, usually nestled under a cooling mechanism, is where all the computational magic happens. Every single action you perform on your computer, whether you're typing an email, loading a web page, launching an application, or even moving your mouse, goes through this tiny but mighty processor. It's constantly performing billions of calculations per second to interpret your commands and execute them flawlessly. Despite being roughly the size of a postage stamp, this component often carries one of the heftiest price tags, and for good reason. It's literally processing every instruction that makes your digital life possible. Moving on to the visual artist of your system, the graphics card, commonly known as the GPU. While the CPU handles general computations, the GPU specializes in rendering everything you see on your screen. This component becomes absolutely critical when you're gaming, editing high-resolution videos, working with 3D models, or running any visually intensive application. GPU contains thousands of smaller cores working in parallel to create the stunning visuals and smooth frame rates you experience. It's another premium component that can significantly impact your budget. However, there's an alternative worth mentioning: integrated graphics. This technology embeds graphics processing directly into the CPU, sharing its resources. While this integrated solution is much more economical and energy efficient, it typically delivers modest performance compared to a dedicated graphics card. For everyday tasks like web browsing and document editing, integrated graphics work perfectly fine, but demanding applications might require you to reduce quality settings to maintain smooth operation. Let's discuss where everything gets stored. The traditional hard drive. This metal-encased device is your computer's long-term memory vault. Inside, you'll find spinning magnetic platters and a read-write head that moves across them to access your data. It stores your operating system, all your installed programs, documents, photos, videos, and everything else you save. The beauty of hard drives is their capacity. They can hold massive amounts of data at a relatively low cost. However, there's a significant trade-off: speed. Because of the mechanical nature of spinning disks and moving parts, accessing data can be relatively sluggish. Additionally, the mechanical components make it more susceptible to failure over time. This brings us to a crucial component that bridges the speed gap: RAM, or random access memory. These slim modules plug directly into your motherboard and serve as your computer's short-term, ultra-fast memory. Here's how it works in practice. When you open a program, your computer loads the necessary data from the slow hard drive into the much faster RAM. This way, your CPU can access frequently needed information almost instantaneously without constantly fetching it from the hard drive. Think of it like this: your hard drive is a massive warehouse where everything is stored, but finding specific items takes time. RAM is like your workbench where you keep the tools and materials you're currently using right at your fingertips. The crucial difference: RAM is volatile memory, meaning everything stored in it disappears the moment you power down your computer. That's why unsaved work vanishes during unexpected shutdowns. Now let's explore the modern evolution of storage, the solid-state drive, or SSD. This component performs the same fundamental role as a traditional hard drive, storing your data permanently, but it does so without any moving parts. Instead of spinning disks, SSDs use interconnected memory chips similar to what's in your smartphone. This design makes them dramatically faster, more reliable, and more resistant to physical shock. Many modern computers use SSDs exclusively, while others combine them with traditional hard drives, using the SSD for the operating system and frequently used programs, while relegating bulk storage to the cheaper hard drive. While SSDs cost more per gigabyte than traditional drives, their performance benefits have made them increasingly standard in contemporary computing. Heat management is critical in computing, which brings us to cooling systems. When your CPU and other components work hard, they generate substantial heat. Without proper cooling, this heat can throttle performance or even cause permanent damage. Most systems use air cooling with fans strategically positioned to exhaust hot air and draw in cool air, creating continuous airflow through the case. The CPU typically has its own dedicated cooler mounted directly on top. For enthusiasts and high-performance systems, liquid cooling systems offer superior heat dissipation, though they're more complex and expensive. Proper cooling isn't just about preventing damage. It ensures your components can maintain peak performance under demanding workloads. Powering all these components requires the power supply unit, or PSU. This critical but often overlooked component converts the alternating current from your wall outlet into the various direct current voltages that your computer components require. Different components need different voltage levels, and the PSU handles this conversion safely and efficiently. Choosing a quality power supply with adequate wattage for your system is essential for stability and longevity. It's worth noting that laptops incorporate their power supply differently, with an external adapter and an internal battery providing portable power. In our wireless world, connectivity is essential, which is where the wireless network card comes in. This component, whether built into the motherboard or added separately, enables your computer to connect to Wi-Fi networks without physical cables. Without it, you'd be limited to wired Ethernet connections, which, while reliable and often faster, restrict mobility and placement options. Most modern computers include wireless capability as standard, but desktop systems sometimes require a separate card to be installed. Finally, everything we've discussed needs protection and organization, which is where the computer case comes in. Far more than just an aesthetic shell, a well-designed case provides structural support, organizes cable management, facilitates airflow for cooling, and protects sensitive components from dust and physical damage. Cases come in various sizes and configurations, from compact mini tower designs for space-conscious setups to massive full tower cases that accommodate multiple graphics cards and elaborate cooling systems. The case you choose affects not just appearance, but also how well your system stays cool, and how easily you can upgrade components in the future. Understanding these components and how they work together transforms a computer from a mysterious black box into a logical system of interconnected parts, each playing its vital role in delivering the computing experience we often take for granted. Whether you're building your first PC or simply want to understand what's inside your current machine, knowing these fundamentals empowers you to make informed decisions about upgrades, troubleshooting, and future purchases.